Hello everyone. Before watching the video, please subscribe the channel. Let's start. Quantum physics. Ha 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 ha. That is tough. The laws that govern the behavior of smallest components of our universe, such as fundamental particles, atoms, and molecules, is admittedly a tough subject, a complicated path of intricate mathematics and scientific theory. If this has been your experience, don't worry, you're in very good company. Not joking. Respected scientists, including Albert Einstein, felt the same way, and made many attempts to prove that these strange new theories couldn't be correct. Each attempt, however, failed, and instead reinforced the reality of quantum physics in contrast to our conventional intuition. But this is good news. The properties buried in quantum theory hold great promise for exciting, real-world applications. So how do we make sense of these bizarre new rules? What really makes quantum physics so different, so strange, and so promising? To start, let's take a look back to 1900 and the work of physicist Max Planck, who first drew back the curtain on the mysterious quantum world. That year, Planck was embroiled in a nagging physics problem: how to explain the radiation of light emanating from hot objects. At the time, there were two conflicting laws, neither of which was quite right. One law, Wien's law, could accurately predict the experimental results of ultraviolet waves, but fell apart when it came to infrared waves. Conversely, the Rayleigh-Jeans law covered infrared waves, but didn't work for ultraviolet. What Planck needed, then, was one law that would correctly apply to both ends of the spectrum. For the birth of quantum physics, the details of Planck's solution to this problem were far less important than the trick he used to arrive at it. This trick, which Planck later on called happy guesswork, was simple but unsettling. The radiation energy had to be chopped up into tiny packages, or particles of light. Based on everything physicists knew at the time, this claim was outrageous. Light was understood as a wave, which left little space for particles of light, nowadays known as photons. So now light could be both. We now understand that it's not just light, but all of the fundamental components of our universe that embrace this dual nature and the other properties of the quantum world. When it comes to strange quantum properties, this dual wave particle nature is just the tip of the iceberg. One of the most striking concepts is that of quantum entanglement. It can be illustrated like this: imagine being the proud parent of two children, Iron Man and Hulk, who have just hit the age of disagreeing with each other all the time. Ha 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 ha, I said they imagine. So they both like mac and cheese as well as pizza. Sadly, this is no longer sufficient to guarantee a drama-free dinner. As a counter-strategy, you and your partner team up and question Iron Man and Hulk simultaneously in different rooms. This way, they cannot coordinate their dissent, and you have a 50% chance of random agreement on the dinner choice. Believe it or not, in the quantum world you would be doomed. In an experiment, the two parties could be photons, and the dinner question could be a measurement of their polarization. Polarization corresponds to the direction of oscillation, moving up and down or from side to side when light behaves as a wave. Even if you separate the two parties, eliminating all communication, quantum physics allows for an invisible link between them known as entanglement. Quantum Hulk might change his answer from day to day, even pizza gets boring after a while, but every single time there is perfect anti-correlation with quantum Iron Man answer. If one wants pizza, the other opts for mac and cheese all the time. As I told, that would be a doom day if they don't get both their choices. This is just one example of the many bizarre properties we know to be true based on careful calculation and experimentation. Hope you had an idea about what happens in quantum world. Thanks for watching this video. Bye bye.